Yeah, minor planets. That's basically what we're talking about. You know, there were things that happened again this week that didn't happen last week. One of the things, just to bring you up to date, remember last week I said, by the way, the Hubble's dead?
Right.
Well, by the way, it's not. Because apparently, for some set of reasons that I don't understand, they took they did something the equivalent of taking the Hubble and shaking it,
Shaking it out.
which is of course impossible because there's no place to stand to hold the Hubble to shake it.
It's called the hand of God.
The hand of God. Now, so what happens is, you know that a cat, when it's falling, you know, if you throw a cat out a window, it will right itself, you know, and the way it does that is it has control over its momentum, angular momentum, by sticking out its feet and doing whatever it is to orient itself by literally moving itself. It has no control really in those few seconds, but it can orient itself by moving its arms and legs. If you move an arm this way, the body goes the other way. Right. So that's what the Hubble did. It moved itself a couple of times and sort of shook itself, and somehow miraculously it's working again.
It came alive again.
Yeah. So
Wow.
I don't know. What the other thing that is happening let's see, it's happening within actually a month, 2 months, is they have decided now, a while ago, that it was time to go visit some place beyond Pluto. So they're on their way to a planet, well, minor planet, that is beyond Pluto. When they passed Pluto, they had already spent hours and hours of Hubble time looking to find some place they could go that would be in the direct path of where they were already going. And they found a planet, minor planet, to go visit, and that visit will take place on January 1st of 2019.
Ah,
First,
2019?
they will be visiting an astronomical body further out in the solar system than anything has ever been visited before. And in the future, this sort of thing can happen again. One of the things they did this week, somebody came up with a calculation that said, if we go back to Pluto, Pluto has this really cool moon called Charon. So this is the Earth, and this is the moon. Okay. Charon, that's Pluto now, and this is Charon.
ooh,
So Charon is, well, maybe not quite as big as that, but Charon is much bigger proportionally to Pluto than the moon is proportionally to our planet. And it's also much closer, which means that Charon is capable of performing miraculous stunts of astronavigation. And the stunts that you want it to do is, you have a spacecraft that's headed, you know, to Pluto, but why headed to Pluto? Why not have it circle Pluto and then, you know, come into sort of an orbit, but then come out here and then go around Charon, and then the sky's the limit. Once you've got two bodies in motion, those two bodies can kick a third body anywhere it wants to go. So they can continuously use Charon to send a spacecraft that would in some time orbit Pluto anywhere else, including way out there. So it's possible that in the future Charon is going to be the stopover, last stop before the final exploration of the outer solar system, before they really get big rockets. But none of that is happening in your lifetime. Okay? So I can tell you that this lifetime, something that might happen in your lifetime is Sedna, is Planet 9. Planet 9 is all the rage this month because they found yet another planet out there that is doing strange things. Let me show you, first of all, my simulation of the planets in the solar system. When I say it's my simulation, it is. What I did is I took a computer program which is publicly available from the Museum of Natural History, and which is what I'm starting to run now, and that it's publicly available. So the data that it uses in that simulation is in fact data that you can literally see the data. There it is. See, it looks like a text file. Number here, number here, number here. If you know what those numbers are, you can add other numbers to the simulation, and you can get new stuff. So if you have a pile of numbers that make any sort of sense, and this is not working yet, then I'm going to have to go to the. No, I'm going to go here. If you have a pile of numbers that make sense, you can add that. And what I did is there was this new planet called Sedna that was added to the list of planets, minor planets that had been discovered, and I got so excited about that I decided I needed to have my own Sedna. So this is the simulation as it looks when it comes directly from the Museum of Natural History. You can get this on your computer, and it looks like this. It's just the orbits of the planets, and that red circle is Mars, and then that's Jupiter, and then that's Saturn, and that's Uranus, and then that's Neptune, and then there's Pluto. So this is the solar system. This is our solar system. Pluto, as you can see, is weird and different and does its own thing, as if it doesn't belong. And you can see at some point when they decided at some point that it didn't belong, because at some point they discovered a number of other planets in the solar system that they wanted to call planets. This one in particular, see, I added this one. This one was not part of the Museum of Natural History's set of planets. This one, this orbit, you see, is further out than Pluto's, and that was a planet. Its planet now is called Eris, and when they discovered Eris, they said, either we're going to have to go with 10 planets, or we're going to have to demote Pluto to a dwarf planet. And at the same time they discovered that, they discovered that one. See, this one. And then they discovered that one, this one. And not long after that, they discovered this one, and that one, and that one, and oops, no, not that one, and this one, nope, this one, and that one, and that one, and that one, and that one, and this one, and that one, and that one, and that one, and oh, that's it. Okay, so that's what the solar system looks like, and the thing I'm really impressed with myself about is that I gave this simulation that data. And I actually called up the guy who wrote the simulation in the first place, and I didn't know who he was, but it was recommended, and he started helping me do this. So literally, he gave me the tools to be able to add these orbits to the simulation. And I really feel bad because there's something I haven't added. There's 2 or 3 new planets that are not in here, and but one of them, the most exciting one is, and that's this one. That one. Look at that one. That one is called Sedna. See how far out it goes? Well, when Sedna was discovered, that became a real, doing this whole thing, it's all over there, didn't point the camera towards it. What's the value of doing a videotape if I'm not pointing the camera towards it? So maybe this videotape will go nowhere. That one was the clincher. It said, excuse me, this doesn't make any sense. Why doesn't it make any sense? Because all the other planets of the solar system look like they have been influenced by all the other planets in the solar system. Look at Pluto. Pluto, I'm going to turn off all those other planets and turn them on all at the same time. Okay, so we come in here. Any more to turn off? Yeah, I have to turn off some more. Okay, so there's Pluto. Actually, Pluto's still not alone. I have to turn off Varuna and Ixon. Okay, now Pluto's all alone. Pluto actually goes inside the orbit of Neptune. It actually gets closer to the sun than Neptune gets to the sun. So clearly, Pluto and Neptune have a relationship with one another, and that relationship is called resonance. Pluto knows that if it gets anywhere near Neptune, when Neptune is around, that it will be influenced by Neptune. So Pluto has decided to be as far away from Neptune as it can be when it's close to Neptune. So Pluto and Neptune, they share opposing orbits and they never get close to one another, but they are in fact influenced by one another, because anything that isn't doing what Pluto's doing is going to get thrown out. And when it gets thrown out, it would get thrown out, but it would always come back again. Out and back, because always when something gets thrown out, it comes back to where it gets thrown out. That's the way orbits work. You go back and forth. You always come back to where you were thrown out. So nothing has been thrown out from this orbit except maybe Sedna. Look at Sedna. Maybe Sedna was thrown out. But no, that's the thing. Sedna is so far away from Neptune that we are closer to Neptune than Sedna is. In fact, Sedna is 3 times further away from Neptune than we are from Neptune. Sedna is really far away from Neptune. It has nothing to do with Neptune. If it has nothing to do with Neptune, then why does it have an orbit like that? Because surely Neptune would have been the guy at fault to have caused that sort of orbit. But it didn't. It couldn't have. Neptune's too far away. Maybe it's planet 9. Maybe it's planet 9. So do we have any evidence for planet 9? Well, yeah, we do. So let me show you what happened in the last week or so. They found a planet out there, which they haven't found planet 9. They have found another planet that does weird things, and I'm going to go back and see if I can find that again. Okay, so look at this picture. Not that. Oh, sorry. Going back to what I was talking about before, because I didn't finish that conversation, the spacecraft that went to Pluto is headed for a minor planet called 2004 MU69, and it's going to reach that minor planet on January 1st, 2019.
2019.
So essentially, New Year's Day 2019, just like there was a flyby of Pluto and everybody got really excited. Well, this is going to be a flyby of a minor planet right there, small, I don't know how many miles across, but nothing gigantic. And they're going to be taking pictures, and we should see something as it gets closer and closer. But it's a really small object, and it will be flying past it at gazillions of miles an hour. So it's going to have to do with his cameras, and keep tracking it as it passes. But it'll do that. And then it'll send back the data in a year. It takes about a year for the data to get back. So they'll send out a couple of snapshots, and then they'll send the rest of the picture over a period of a year. So it took a year for the photos from Pluto to get to us. And now it's taking, it'll probably take some time for these pictures to come as well.
How long did it take the satellite?
Satellite took about 5 years, I don't know, to get there. I'm not sure. I learn these things and then of course I forget them. So 5 years. But what we were going for was this picture. In this picture, remember I showed you Sedna and I wowed you with how that orbit of Sedna is really, really, really far out? That is Sedna. This they call the Goblin, and they discovered it just a few months ago. Actually, it's been discovered, it took 3 years of observations. They announced it just a few months ago. They announced it because this thing is moving so slowly that they literally couldn't figure out its orbit, and they needed to take picture after picture after picture, and after many years, they were able to piece together the orbit, and that's the orbit. That's insane. This, by the way, is another picture, one that I don't have in my simulation. VP 113, we used to call this one Biden for the vice president, because when he was vice president, they called this asteroid Biden, but now it's just VP whatever. So Pluto is right in there, right? Biden is there, Sedna's here, and I wish, I'm going to have to do this. I'm going to get the orbital parameters for this and insert it in my simulation. It's just, I need to do it. But of course I've forgotten how I did it. So that's the problem. But look at that. Now this by itself tells you something that is extraordinary. It tells you that there's more than than the eye can see. There's more of these Sednas. There's more goblins. By the way, the official name is not goblin. It's just that it was discovered around Halloween, and the initials that are given to it by the Astronomical Naming Convention, there's a convention in which it gets letters and numbers, was TG 387, and TG 387, well, TG is the goblin, okay? So that's why it's the goblin, okay? It could remain the goblin for all we know, because they have naming conventions, they come up with names. Sedna was not the name that they originally, the discoverers came up with. It's some other naming convention gave it that name. But anyway, why does this tell you that there's more of these? Because you can only see these creatures, these minor planets, when they're close to us right here, and right here, and right here. If they were here, here, or here, or here, or anywhere along this 40,000 year long orbit, we couldn't see it. It's only when it's here. And only, and Sedna is really here. So it's only when it's close that you can see it. If you can't see it, if you can see it only when it's close, what does that tell you? There are 3 things that are close and you can see them. It means that there are thousands of others just like this that you can't see because they're somewhere along the elliptical path and they can't be seen by us. So thousands of minor planets. These are not just a rock. These are minor planets. These are things that are round, big enough to land on, just like the asteroids in The Little Prince, but bigger. So you can actually, they're round and you can walk around them. They're hundreds of miles across, these things, whatever they are. And for every one of these things that's hundreds of miles across, there are millions more that are tens of miles across. We think there are trillions of these things that are much smaller than this. But when it comes to much larger, if there's trillions that are smaller, thousands that are this size, what about hundreds that are bigger, tens that are bigger than that, and one that's bigger than that entirely that explains them all? Yes?
We can only take something and point it one way?
It goes one way, and
One way, so
we can only point it in one way.
we'll say to the left. So does that mean we could assume that all the other ways, north, east, south, wherever, there are many more that we have no idea about? Because we only point at one spot.
Okay, so Barbara is saying, we only point at one spot. Isn't it possible that there are other places where we're not pointing, where there are other things to be found? Is that your question, more or less?
I guess so.
So I'm trying to repeat it for this video. Well, Barbara, as usual, you asked the right question. Because it turns out that in order that the people who are doing this are limited in their funding. And so they look to where they think the things are. The old contact lens dropped on the ground, nowhere near the street light. It's better if you look near the street light because the light is better, but the contact lens is over there and you're looking here. Why? Because the light is better. Well, that's how they do astronomy as well. They do astronomy where it's more likely that there is something than looking here where it's not likely that there's something. So all the observations have been done essentially looking along this line of sight. Essentially in this direction, along this line of sight. And having done that, they conclude that it could be a planet 9. Let me show you more about that. This, I think, maybe not in this video. I mean, maybe not in this one. Well, no. I'm going to try one more look, and then we're going to stop looking at this, and I'll tell you what I'm intending to see. Okay, in fact, I'll draw it. Okay. So, let's say that's the orbit of Pluto. This is, the sun, and they're discovering that there are lots of orbits that are in the same direction, more or less, passing the same part in space. They all seem to be passing this one spot in space where they all seem to have been kicked out of. And when you look at the pictures of all these different orbits, there is a sense that they all have a common starting point. And they're thinking, well, if there's a common starting point, then there must have been something there originally that was there to kick them out. So that would be planet 9 that does something like that. And when planet 9 would pass this point, and one of these guys were passing this point, they would get kicked out into one of these orbits while planet 9 is doing its own thing. Planet 9 could be as big as planet Earth, or even bigger. But planet 9 might be all the way out here right now and invisible. So they're saying, we got to look out here. And they think they may find Planet 9 within the next 10 years. So stay tuned, stay alive, and we might find a ninth planet. Yes?
What distance are we talking about? 1 light year, 10 light year?
Okay, that's a good, what distance? Distance is a hard thing because I actually know the answer to this one, but distance is a hard thing because it doesn't mean anything when you say things. In terms of light years, the nearest star is 4 light years, okay? If the nearest star is 4 light years away, how big do you think the solar system is in terms of light years?
Our solar system?
Our solar system,
100,000.
100,000 light years?
Yeah.
No.
Milky Way?
No. Our solar system,
Oh, our
the 9 planets, the 8 planets. 8 planets are really here, right? They're all bunched up around the sun, and then you have to walk 4 light years to get to the nearest star. How big is our solar system? If the nearest star is over there, okay, and we're the solar system, how big is our solar system? Okay, so
Not very large.
okay, well, I'm trying to give you the sense that it's not large, and then I'm going to tell you that it is large. Okay, that's the way I was going with this. I'm trying to trick you into one answer, and then you come up with another answer. No, the solar system is quite large. It's 1 light year in diameter, which is 1 of 4 light years to the nearest star. Why is it 1 light year? Because if it was any bigger, the nearest star would have something to say about it. So as much as we can control with our gravity is as much as we own. And we own 1 of the 4 light years between here and the nearest star. Okay? That means, so we own 1 trillion or more minor planets that are part of our solar system, of which I'm just discussing a couple. This guy, the one that we just discovered, okay, is the not the Planet 9, but the one that we just discovered, Goblin. Goblin is so far out that it touches the inner part of the outer cloud that forms our solar system. There is I have pictures of all these things. Why I'm drawing this on the board, I have no idea. So this is the sun, this is Pluto, okay? And then let's say there's an asteroid belt here, okay? You know, and Jupiter and Saturn and like that all there. This, beyond Pluto, there's a band of stuff. Band of stuff. And that band of stuff has a name, and it's real. It's the Kuiper Belt. And you all know the name of one Kuiper Belt object. The first Kuiper Belt object ever discovered, its name is Pluto. Okay? Pluto is the first. There are 20 that I was showing you on the screen that are also part of the Kuiper Belt. And Sedna is doing its thing like this. Okay, more like this. But the one Goblin went out as far as here. Out here, there's more. Told you about the trillions of things.
And that's all the Kuiper Belt?
No, this one's got a new name. This one's called the Oort Cloud.
Wow.
Oort Cloud. And why do we know there's something out there called the Oort Cloud? Because back to the demonstration, back to my thingy. Okay, so there's the solar system. There's Sedna, okay, and that's a comet. That's a comet. Look at the orbit of the comet. That's the orbit of a comet. It goes, so that is part of my simulation. I put that comet in myself, and then, for good measure, I put in 20 more.
For good measure,
Yeah.
20.
Those comets are coming from the Oort cloud. These are not like things that how do we know about this Oort cloud thing? We can't see anything in it. Okay, if we can't see anything, how do we know it's there? It's because these comets keep dropping on us from the Oort cloud. And so if you see, they said we never saw this comet before. It's never been seen in human history before. Well, the reason is these things take millions of years to come down and hit and poke into our lower solar system. So this is just 20 comets. There are hundreds and thousands and probably tens of thousands of comets that we know of. I only have 20 orbits plotted. These are real orbits. Yes.
If Halley's Comet comes around like once every
76 years.
75 years.
Yes. It's not part. Halley's Comet comes every 76 years. It's not part of the Oort cloud. It's part of the Kuiper Belt. Right.
Is it influenced by our sun in gravitational?
Everything's influenced by our sun.
By our sun?
Is it influenced by our sun? Yes. But I think you're asking a different question when you say, is it influenced by our sun? What is it that you're asking? Because you know that it's influenced by the sun.
It stays within the same trajectory?
Yes. Yes.
But this planet 9 goes even further out. Is that what it is? It takes longer to come back?
It's even further out. It takes even longer to come back. Yes. Yes.
So why is it when it reaches, like the sun, that we can't see it with telescopes?
Why is it that we can't see what? When
This ninth planet.
the ninth planet is, why can't we see it? First of all, we don't know where to look. See, the sky is big, even though it doesn't seem big. It seems like, if I look here and I look here and I look here, I got it covered. But you're looking through a narrow soda straw, and when you're looking through a narrow soda straw, you can keep pointing it all over the place and still miss everything that's over there because you're busy looking over here. Don't look at the whole sky with a narrow soda straw. It takes a long time or a lot of money, and neither of those things have been done. You have to also, if you're looking through the soda straw at something that's far away, you have to keep it pointed at that one spot so that something that's dim lights up because you're exposing it for long exposure. But meanwhile, while you're doing that, the telescope is other people are going, I want the telescope for my work. No, you can't have it. I'm busy staring at one empty spot in space, hoping there's a planet there, and everybody else wants the telescope time. Eventually, you have to relinquish the telescope time to other people who want it, so there's not enough time being spent looking for these planets. It's all a matter of money. And we're putting more and more money into this every year, so we'll find with better and better telescopes, so we're going to find it someday. Yes, Bob.
In line with what she was saying about
Can we see something?
have we ever actually sent anything to the other side of the sun from our perspective? Might there be things hanging out, and because of orbits and where they're placed, big things on the other side of the sun that might be equivalent in size to Jupiter, or things that we just
Okay,
don't
so
know?
Barbara just
Just
asked.
because of where
Barbara just asked this incredibly crazy question, which of course isn't a crazy question. She asked, have we ever gone to the other side of the sun to see if maybe there's something hanging out on the other side of the sun that we don't see? And I say it's a crazy question because how could that be that something could be hiding behind the sun that we haven't seen? We've been everywhere in the solar system.
But don't we orbit the sun? So
We-
there's
and
no
we orbit the sun.
So there's no backside.
So there's
like
no
the moon.
backside to the sun. So
There's
how
the backside of the moon, but not to the sun.
So the backside to the moon, but not to the sun. So how
Right.
how could there be something hiding behind the sun?
Right.
Reason tells you.
Exactly.
Okay. The name of that planet is called Planet X. and it has been theorized by, I wouldn't say scientists, but let's say semi-scientists, knowledgeable people like Barbara, who have a reasonable question. Why can't there be an Earth in orbit around the sun, same orbit as the Earth is in, but exactly on the other side of the sun, in such a way that as we go around the sun, it goes around the sun, and it hides behind the sun as we go around the sun? Why couldn't that be true? Okay?
Same orbit.
Okay, so if you wanted to research that, there is an enormous amount of stuff on that. Okay, and lots of and a lot of stuff that starts out by sounding reasonable, but ultimately it isn't reasonable. Ultimately, there are lots of simple reasons why it couldn't be so. Okay, including the fact that the Earth's orbit isn't a circle; it's an ellipse. So something hiding out on the other side of the circle would have to be hiding out at the other side of the ellipse, and that's not reasonable. It's not at all reasonable, but it's not impossible. Okay, imagine the thing, so Planet X, it's real, it really exists in the literature, and and it's more reasonable than flat Earth. Okay, flat Earth is really crazy. This one isn't. This one, people still talk about it all the time. So there's the Oort cloud. The Oort cloud. I'll show you the Oort cloud because this simulation actually has a simulation of that, and that's this. This is a wireframe sphere that surrounds the sun, and that wireframe sphere is 1 light year radius. That's 1 light year, or 2 if you count the diameter. So that's how big the Oort cloud is. 1 light year out, and the comets are coming from the Oort cloud. Well, now, let's see what's next. So what we're talking about is minor planets. Anything that isn't a planet and that isn't a comet automatically becomes a minor planet, including asteroids. Yes?
So the Oort cloud is part of our solar system.
It's part of our solar system.
Didn't they say something came by recently that they said was not part of our solar system?
Yes.
Asteroid something.
Yes. I'll show you that.
And how can they determine it's not?
Okay. How did they? Wasn't there an asteroid that wasn't part of the solar system? Didn't it come by recently? And how did they determine that it wasn't that? And so there's an app. Actually, it's it's an app. It's called Universe Sandbox, and it lets you play with the universe. It actually lets you do all sorts of strange and wonderful things, including blowing up things. But we're not going to blow up things today. And if this thing comes in, hopefully there it goes. Okay, so this is a simulation that comes up normally. It is our solar system. It's a very nice one. It comes with music. Okay, and this is our normal solar system, and you can pull out, and you can see. It's just wonderful. I mean, there's Pluto and Neptune and Maki and Humana, and there's Sedna. And I'm going to turn on the view, and I'm going to view the whole orbit, so you can see it. You can see that Sedna is really out there. So this is a lot of fun, this simulation. It's better than the one I did. This is theirs, and I love it. And there's a to answer your question about something coming in from out there, they have a simulation of that. You just have to find it. pay attention to the music. Yeah. I have this one, which is okay. So this orbit that you see here is a theoretical. This is the orbit of that particular comet or asteroid that came in from someplace else and left. You can see the orbit. I pull out, and the orbit continues to go in and out as I pull out. So the reason they could tell is because that's the way the orbit looks. It's a hyperbolic orbit. In, the sun is here, and out. There are three kinds of orbits in the world. Three and only three. There are circles. Nothing's a circle. Because everything is not quite a circle, so everything is an ellipse. And everything is an ellipse except if it's not an ellipse. Then it's a hyperbola. Hyperbola is an ellipse with only one focus, whereas an ellipse has two focuses, one there and one there. And as this thing gets wider and wider, the focus gets further and further away. And as the ellipse gets more and more elongated, one focus essentially ends up at infinity, and then it's a hyperbola. So that's your, the name of that object is Umawamawa. And it recently came through our solar system and left. I think it's sort of sad, that it came to visit from literally another star, and it didn't stay so we could say, check it out. I mean, literally, there's something from another star came here, invited us to visit, but we are too primitive to be able to visit it. There was a science fiction story called Rendezvous with Rama, written by Arthur C. Clarke. And in the Rendezvous for Rama, there was a spaceship that they could determine was a spaceship. And they determined that it was a spaceship, so they decided to rendezvous with it, except that it was on a hyperbolic orbit. So they essentially had to go to it, they had to examine it, and then they had to leave it before, because of course they had to match speeds. So when you match speeds, you are also on a hyperbolic orbit. And the amount of energy that takes to do that is ridiculous. We don't have anything remotely approaching something that could go that fast in the direction you want it to go to and get there at the time you want it to get to. We'd have to be rockets beyond our technology or even our imaginations are required to do that. But they went there and they did it, and they discovered it was an artificial satellite built by aliens. And the exciting sequel to that was everything that they found on that spaceship was done in threes. They realized the Ramans were particularly devoted to the number 3. So as the end of book 1, we had the impression that there might be another spaceship coming. And yes, indeed, Rendezvous with Rama 2 was the second book, and followed by Rendezvous with Rama 3. So they're good books. What did I want to show you? Planet 9. Okay. Come in, simulation of Planet 9. Here you go. So, remember I showed you they all bunched up. Well, they all bunch up right there. See where they all bunch up? They're all bunching up right around there. So, when you invented Planet 9, you invent it in such a way that it can cause that bunching up. And there is, this one is the orbit of Planet 9. Planet 9 is here. Of course, nobody's found it. No. But I think the extraordinary thing to me is, and I think the music is appropriate, I think the extraordinary thing to me is that there are so many things that are part of our solar system. It seemed in some level that the solar system was a lonely place to be. You go from the Earth to Mars, there's nothing along the way. You go from Mars to Jupiter, and there's some asteroids. Okay, so there's more of something. But now we realize that there's a lot, that the space between, in our solar system, is filled with trillions of destinations, trillions of places that we could go to, separated by millions of miles each one. But there are trillions of bus stops. Try to imagine a transportation system far, far into the future where individual people on this earth who are very rich have bought a minor planet or two for themselves. And they live on these minor planets. But of course, they wouldn't have their own rocket ships because perhaps they would be shuttled from minor planet to minor planet by a space shuttle bus. And so perhaps in the future there would be buses between the trillions of planets and trillions of human beings living on trillions of planets along the solar system. And lots of activity moving back and forth. The solar system, while being an empty place, is also a place that's just filled with places to go. And that's what I'll talk about next time, is places to go in the solar system. But you can ask your question.
Well, I didn't have a question, I was trying to tell you.
That the sound was too high. Okay,
Will
yes.
Will the web help us see some of this?
Will the
The new telescope.
will the James Webb help us see some of this?
Right.
Well, it certainly is going to help us see things. It sees things at a different wavelength, infrared.
Right.
So to the extent that things are different in infrared, it will help. And infrared is very useful for penetrating a fog. So for example, if you have you ever noticed that your fog lights in your car are a different color? Some of them are orange. And the reason that they're orange is because that's closer to red. And red will penetrate the fog better than white would. But red is also hard to see, so they make it a little orange sometimes, so it will penetrate the fog. Infrared penetrates the fog. The fog is created by the dust between the planets, the dust in interstellar space. So we can see much further through the dust, so it'll see things, but not planets, probably not.
If they look at something that they call in our solar system, and they're looking at whatever technology they're using, if something is speculated to come from outside our solar
If
system,
something's
will
right.
there be something that will look different, that is made of something else? How the heck can they determine?
Will something out of our solar system, will it be the same or will it be different? Stuff. Well, first of all, that thing that came from outside of the solar system, we couldn't do much in the way of measuring. The elements, the chemical elements, will be the same because there's only 92 of them. and there's no surprises there. So the only question is the proportion of them to each other. That's where you can have surprises. That's where you can have less uranium, more uranium, more nickel, more iron, not so much lead, much more lead. Those proportions could be changed. And we have not the instruments to be able to determine that sort of thing. So we can't say that it's different. The things that are different are interesting, but we literally have to land on those things and take a sample and do measurements on those samples. So no, we can't tell it's any different. Yes?
I just wanted to tell you that I saw the first man, and it was excellent.
First Man was excellent. Is it still playing?
Yes, it hasn't come out yet.
Although I think it's in theaters, isn't it?
Well, maybe
Yeah.
I saw it as a screen.
Yeah.
The attendance sheet is
Oh,
circulating.
attendance sheet. I didn't do attendance sheet. Please don't go away until the attendance sheet. Listen, the attendance sheet this time is yes, over there. This is last week's attendance sheet, okay, which I didn't produce a new one of. So please put an X next to your name, okay? An X, because many people have circled and checked it and put an X. So they'll know it's this week's as well. Yes.
Is that true that when you travel closer towards the center of our Milky Way, it gets brighter because there's a more aggregation of stars?
It does get brighter as you get closer to the center of Milky Way.
This is,
There's more black holes on
Yeah,
the
some
roof?
might not.
The center of the Milky Way has black holes at the center, but that
More than
doesn't.
one black hole? Or just
There is a theory that there's more than one black hole there. Yes, but that doesn't make it bright so much as the concentration of the stars themselves make it bright. They tend to congregate where the gravity is. So if there's more gravity at the center, because of the black holes, for one thing, and also because of the suns that are already there, they tend to pull in other things so that there's more stars near the center. It's much brighter towards the center of the Milky Way.
more hotter.
And hotter. Well, hotter is a relative term. You wouldn't burn up because it's so really cold there, because outer space is cold.
Sorry.
So yeah, it's hotter in the sense if you really get close to a star, it's hot. If you get, we have a spacecraft that's all the way really close to our sun. It's close to our sun right now, and it's really hot, except only the part that's facing the sun. The part that's not facing the sun is really cold as hell, and so the vacuum of space isn't hot. The sun is hot. You know when you face the sun, it's hot. Okay, the sun is hot. The closer you get to it, it's hot. But space around it, not so much. You know. So if you put yourself under a sunshade, not as hot anymore. If there wasn't any atmosphere around you, you'd be freezing cold. Not to mention explode.
The temperature in space in itself, away from the sun, many thousands and thousands of miles, is really, what's the temperature?
The temperature of space is basically absolutely zero.
Absolutely
Yeah,
zero.
the temperature of the stars that are of the stars are not. So it really depends upon whether or not you're talking about baking from the nearby star or whether you're holding an umbrella. If you're holding an umbrella, you freeze instantly at zero, below zero, 400 degrees below zero, that kind of below zero, okay? But you take away that and suddenly your chest heats up to 5,000 degrees. It's the star that's heating you. Space is cold. Space is cold. Yes?
Just an aside, and I haven't read it, but I just opened the science section, and on the top it says Stephen Hawking in a posthumous paper saw an exit from black holes.
Yeah, so he definitely wrote a paper in which he saw a way that things could leave black holes. But that was the source of his fame in the first place. He said that black holes evaporate.
Okay.
Okay, so it's not quite as spectacular as all that. Yes.
There's also a new book out by him. I don't remember the title, but I have it.
There's a new book
Also
by
out,
Stephen
yeah.
Hawkins.
Some people finished it after his death.
He keeps on plug in.
Well,
I
it's
started
fabulous.
to read some chapters, it sounds interesting.
Really? That's interesting.
What's it about?
What's it about?
Everything like what is life and it's simple chapters also.
What's it called?
I don't know. That's what I
A
don't
new book by Stephen Hawking.
Yeah, that's in the book.
It's,
So,
yeah, amazing.
Who died?
He died a few months ago, right? Okay. Listen, the election day is next week. Okay.
Right.
I am not canceling the class, although 2 hours, 3 hours before this class, I will be upstate voting. Okay, and then I'm coming back to the city that same day. So there is a small possibility I'll be late to this class. I will call Kurt or Aaron or Elaine to say I'm late if I'm going to be late. But I expect to be here on time. I expect the lecture will be terrible, okay? Because I will not have prepared sufficiently, but I did prepare 3 lectures in a row, so we'll see what happens. And then the week after, I am going to cancel the class. And the reason for that is my son has come in after having defeated Trump. He's going to be coming in to elect, to celebrate with his family. And if you want to defeat Trump, okay, and I have to turn off this now.